Okay, so here we go with our last section, 9.5 series. And just want to let you know that series really is the same as a sequence, except for you're adding together the actual terms in your pattern. So that is the only difference. And we'll use a lot of the information that we have from section 9.4. So if I have the sequence 3, 5, 7, 9, 11, 13. Okay, so that is a sequence, right? It's just a pattern. It happens to be arithmetic. We're adding 2 every single time. If I do this to it, put plus signs in between, now it's a series, okay? So the series is just the same pattern, arithmetic in this case, where we're just adding those together. Okay, in math, what we like to do is we like to use shortcuts, okay? So you will see a sigma symbol telling you that this is a series, okay? So when you see sigma, it's just telling you to take all of the terms in a specific explicit formula and add them together. This tells you which term to start with. This tells you which term to end at. And this is actually the rule for the sequence, or the explicit rule. So if you think about what this explicit rule is, so a sub n is the first term plus n minus 1 times the common difference, which we learned. So we have 2n minus 2. Okay, so our explicit rule would be 1 plus 2n. Okay, so you might see this same series written using sigma notation. So this is what it would look like. So sigma, you put your rule here. The rule for the pattern is 1 plus 2n. This is always 1. We're going to start with our first term. And then here, n is the number of the last term. So it's not the value of the last term, it's the number of the terms. So this is the first, the second, the third, the fourth, the fifth, the sixth. So what this tells you, okay, it tells you to do this, is what this tells you. So it tells you, okay, you're going to generate a sequence. This is the rule for generating the sequence. You're going to plug in a 1, okay, which would give you 3. Then you'll plug in a 2, which will give you 5. Then you'll plug in a 3, plug in a 4, plug in a 5, and then the last number you're going to plug in is a 6, and that gives you 13. So it generates that sequence of numbers. What makes it a series is now you're going to add those together, okay? And there's absolutely nothing wrong with grabbing your calculator and typing in those numbers and adding them together. It's very, efficient. There's only 7 terms there, 6 terms, sorry, 6 terms there, so you can just do it that way and add and get an actual number, okay? We are also going to talk about formulas to get that sum. Okay, and so you can do it one of 2 ways. You can type in all the numbers, add them together. You can also use the formulas, okay? Here's a formula for figuring out the sum if you don't want to type them all in and add them together. This is another formula. This is the one I'm going to use the most, but you can use that one as well. Notice this is the formula for arithmetic, though. Okay? All right, so this is a really easy series to work with. It's just 1 plus 2 plus 3 all the way up to a certain value. So it says to find an explicit rule for that sum, okay? So if we just use the rule, remember, was n, and then it's first term plus last term divided by 2 is that formula, right? So for this particular example, the number of terms for A, we don't know. The first term, though, is 1. The last term is n, and we're going to divide by 2. Okay, so that's A. Part B, it says to use that if this were your sequence, okay? So part B, n looks like, oh, it's just going to 100, right? So it's 100, 1 plus n, 100, divided by 2. So you've got 101 divided by 2, which would be 50.5, times 100, so 5,050 would be that one. Okay, so that's just using the formula. Here, situation where you probably want to use the formula rather than type all of that in. Okay, but it's just first term plus last term in your series divided by 2, and then you multiply by the number of terms that you have. Okay, so this next example you can do both ways. You can use the formula, okay, or you can just list out all your terms. Okay, so it says the corner section of a stadium has 6 seats along the front row. Each successive row has 3 more seats. So it's probably, you know, like this corner, like wedge section, you know, where it's 6, and then there's 6 seats, and then there's 9 seats, and then there's 12 seats kind of thing going on there. If the top row has 24 seats, how many seats are in the entire section? Okay, so it wouldn't be too bad to just generate that actual series and add that together. It wouldn't be awful. It's not that long of a series, right? So we'd stop there, and you can type that all in and add those together, right? You could use the formula, okay? So that formula, remember, is the sum is equal to n times first term plus last term divided by 2. Okay, so we do know the first term, there were 6 seats. We do know the last term, there were 24 seats. We have 6 plus 24 there divided by 2. What we didn't know is the number of actual rows, or the number of terms in the sequence. So you can, you know, list them all out to figure out how many terms there are in that series, or you could use your explicit rule, okay, to figure out the number of terms in that particular sequence. So I'm going to just show you how to do it the other way. You know, if you're not going to list it out, be like, okay, the first term was 6. The formula is n minus 1 times d. We are adding 3 every single time, and I know the last row has 24 seats in it. And so if I just use that rule for an arithmetic sequence, set it equal to 24, my last term, that will tell me how many terms I have, okay? So I'm just going to simplify this. So I have 3n minus 3 equals 24. So I have 3, combining those two, plus 3n equals 24, subtract 3, divide by 3. I have 7, okay? Which is what we had before, 1, 2, 3, 4, 5, 6, 7, okay? So lots of different ways to approach this, and I want you to do whatever works for you in this situation that we're in. So n is 7, first term is 6, last term is 24, divide that by 2. So we have 30 divided by 2 is 15. 15 times 7 is your final answer on that. So that ends up to being 105 seats in that section. Okay? So that's just, you have some choices that you can make. You can use the formulas. You can just list the actual sequence yourself and add them together. That's completely up to you, how you want to handle it. Just want to get you comfortable with the notation. Okay, so that's arithmetic. Of course, there's geometric, and so if you're multiplying from one term to the next, it has its own formula. Just one thing you want to maybe add to your formula right here is that you need parentheses. That's supposed to be implied, but so make sure when you're typing that you do include that second set of parentheses around the denominator. So what you need to know here is first term, what you're multiplying by, and then how many terms there are. And then it's 1 minus r as well. Okay, so there's that formula. Let me just give you a quick example of something that will be on your quiz. So let's say it just said find the sum of the first 10 terms. And they give you this, 3, 6, 12, comma, dot, dot, dot. So again, you could generate all 10 terms, add them together. There is absolutely nothing wrong with that. But I'll show you how you can use that formula. So the sum, I'll use the sigma notation, is equal to, you can use S, whatever, it doesn't matter. The first term, 3, parenthesis, 1 minus R. R, we are multiplying by 2. N is the number of terms, 10, parenthesis, and then make sure you do put parentheses around that, 1 minus 2, okay? So type that in, okay? So make sure you're using those parentheses, 3 parenthesis 1 minus 2 to the 10th power, parenthesis, divided by 1 minus 2. And I get 3,069. Okay, which hopefully would be the same as if you generated all 10 terms and add those together. Okay, so there is that. All right, lastly, what if you have an infinite series? And you're like, well, how can you add together an infinite set of numbers? So it goes on and on forever. How can you add that together? Is your answer just going to be infinity? Well, that would be the case if it were diverging, if that sequence was continuing to get larger. But if it's converging, okay, so if the value of your sequence is getting smaller and smaller and smaller, it will have a sum. Okay, and so that's what this is. So it's the sum of a geometric sequence, right? It's geometric right here. If it converges, okay, then that R value is less than 1. So if you're multiplying by 0.25, all your numbers are going to get smaller and smaller and smaller and smaller. Okay? If you're multiplying by 0.34, your numbers are going to get smaller and smaller and smaller in that series. So you will be able to add them up. That last number will be basically 0. So you will be able to add them up. This is your formula, and it's a simple A, first term. It should be a little a sub 1. That's what I prefer. And then don't forget to put parentheses around that. 1 minus R. Okay, so if it converges, if this number is less than 1, you can add them together, and this is how you add them together. Okay. So infinite geometric series, there's your first term, this is what you're multiplying by, okay? That is less than 1, so we do know it's going to converge. You're multiplying by 0.25, okay? So we can just say the sum of this is going to be the first term. The first term is right there, 2 divided by 1 minus R. R is 0.25. Okay? So you are just simply going to type in 2 divided by parenthesis. 1 minus 0.25 or 0.75 certainly would be the shortcut. And you get 2.67 repeating. Or 2.66 repeating. I said that wrong. So I'm just writing it as 2.7 as your sum. Okay, but again, that only is if it is converging, if that value is less than 1, would you be able to add together an infinite number of terms. Okay, so that is it for the very, very last section of PreCalc for 2020. We have 4 examples, which will be similar to the 4 questions on your test from this section, okay? All multiple choice, okay? Good. Thanks, you guys. You did an awesome job this year. This is a very unfortunate situation, and but you did the best that you could. Hopefully this worked out okay for you. It wasn't the best for me either, but you did it. Good job. Congrats, seniors. Wish I could say goodbye a different way, but congrats and good luck to you. Bye-bye.